Questions 21 through 25 of the 2001 Grade 8 Gauss Math Contest. Lines PS, QT, and RU intersect at a common point O. As shown, P is joined to Q, R to S, and T to U to form triangles. The value of angles PQR, STU is. So here we have our diagram. This is angle P, this is angle Q. So since the sum of the angles of a triangle equal 180, this will be 180 minus P minus Q, that angle. And similarly, if this is U and this is T, this angle here will be 180 minus U minus T. And very similarly, if this is R and this is S, this angle here will be 180 minus R minus S. Okay? And then this angle here, use a different color, is a vertically opposite angle to this one. And because of that, it is equal to that one. So if this is 180 minus U minus T, that angle is also 180 minus U minus T. This angle here is a vertically opposite angle to this, so therefore it is equal. It will also be 180 minus P minus Q. And finally, this angle in there is a vertically opposite angle to this one, and therefore it will be the same, which is 180 minus R minus S. So there you go. There's the labeling. Now all the way around, if you add up all the angles, they will be equal to 360. So that's what we need to do. All right, so I'll start with this guy here, 180 minus P minus Q plus 180 minus R minus S plus 180 minus U minus T plus 180 minus U minus T plus 180 minus R minus S, and finally 180 minus P minus Q, like that. Okay? So bring this over here. So this gives me 360 is equal to, how many 180s do we have here? Oop, somehow that got cut. We have 6 of them. So 6 times 180 is 1080. And then we have minus, it looks like 2P, 2Q, 2R, 2S, 2T, and 2U. Yeah. All right. So 180, 1080, we can factor out the 2. Or what we can do, actually, better thing to do is put it on the other side. That way we can get rid of all the negatives. So we'll have 2P plus 2Q plus 2R plus 2S plus 2T plus 2U is equal to 1080 minus 360. So 1080 minus 360 is 720. Factor out the 2 and get P plus Q plus R plus S plus T plus U. And therefore, 720 divided by 2 is 360 will be equal to P plus Q plus R plus S plus T plus U. There you go. That's what they were asking for. They wanted you to figure out right there, what is P plus Q plus R plus S plus T plus U? And we figured that out as 360. So 21, the answer is C. 64 white 1 by 1 by 1 cubes are used to form a 4 by 4 by 4 cube, which is then painted red on each of its 6 faces. This large cube is then broken up into its 64 unit cubes. Each unit cube is given a score as follows. Exact number of faces painted red, 3 gets a score of 3, 2 gets a score of 2, 1 gets a score of 1, and 0 gets a negative 7 score. The total score for the 4 by 4 by 4 cube is. So let's draw a 4 by 4 by 4 cube. So here's our cube, and now let's divide it to show that it's 4 by 4 by 4. So there you have it. You've got a 4 by 4 by 4 cube. And now they paint the cube red. So all the way around, they paint it red like this. So now at this point, now that it's painted red, we have to figure out how many cubes have 3 red faces, how many have 2 red faces, 1 and 0. All right, so let's make a little table here. So red faces, number of red faces, how many of those, the score, and the points. And then we'll be able to figure this out. Okay, so here we go. The number of red faces being 3, how many of those do we have? Well, let's look at this. Immediately I see that the corners, see this guy right here? This corner will have 3 red faces, and therefore all the corners will have 3 red faces. So how many corners do we have? We have 1, 2, 3, 4 on the top, and 1, 2, 3, 4 on the bottom, right? These guys are the corners. So that makes 4 and 4, 8. 8 that are of the type that have 3 red faces. So the score for each of them is 3. So the total score is 8 times 3, which is 24. All right. So now let's go to the next one. How many cubes, unit cubes, have 2 red faces? All right, the 2 are these ones right there. This one here and that one there. And then similarly, you'll have those ones in the middle there as well. And on the sides, there'll be 2 more, and on the bottom, there'll be 2 more. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, like that. Okay? But obviously, we're not done. The other side, that's over there, will have the exact same. So they have another 8. And then in the middle, you'll have these ones, right? And these ones. And at the bottom, the same kind of story. And 1 on the other side. So there'll be 2 here, 2 there, and 2 on the bottom. And 2 on the other side that you can't see. So that's an additional 8. So that's 24 in total. So the score there is 2. So the total score there is 48. Now we get to how many have 1. Well, those are the ones in the middle. They will only have 1 face painted red. And there's 6 sides to the cube, and each side will produce these 4. So 6 times 4 is 24, like that. And these get 1 point each, so that's 24. And then how many have 0? Well, 0 will be the ones inside, right? And I can't see those. So the quickest way of doing that, instead of trying to visualize how many are inside, is taking the total, which is 64 unit cubes, they even tell you that actually, and subtract from the 8, 24, and 24. Minus 24, minus 24. And if you do that, you get 8. Like that. So this was how many red faces for that column? It was 0. The score, unfortunately, here is -7, so this is minus 56. So now we have to figure out the total score. So total score of this scenario is 24 plus 48 plus 24 minus 56, and this equals 40. So the answer to number 22 is A. The integers 2, 2, 5, 5, 8, and 9 are written on 6 cards as shown. Any number of cards is chosen, and then the sum of the integers on the cards is determined. Note that the integers 1 and 30 cannot be obtained as sums in this way. How many of the integers from 1 to 31 cannot be obtained as sums? So first, let's write out all the integers from 1 to 31. And let's work through with this. So they're saying, how can you possibly get a number using these cards? So for example, I can't get a sum of 1 because none of these are 1. So this one is one of the integers that we cannot obtain as sums. But what about 2? 2 we can, right? Because 2 is just 2 right there. Any number of cards is chosen. So if we chose only one card and it was a 2, then the sum of the integers on that card is just 2. So 2 can be obtained. How about 3? And this is what we have to do. We have to look at every number, but we can probably do it pretty quickly. How about 3? I can't make 3 because 2 will only give me 2, and the 2 plus 2 will give me 4. So 3 is another one that cannot be obtained. All right? So you just have to go through this long, laborious process. 4 can be obtained. It's 2 plus 2. 5 can be obtained. It's just that card right there. Can 6 be obtained? No. Because if you look at this, there's no way of getting a 6. There's no way of making a 6 as a sum of one or more of these cards. So that cannot be obtained. 7 can be obtained by getting 2 plus 5. 8 is right there. 9 is right there. 10 can be obtained as 5 plus 5. And you just keep going like that. And to spare you the absolute dreariness of that, the only other ones that cannot be obtained is 25. There's no way you can add any of these to get 25. And also 28 and 30. 30 they actually gave you. 1 and 30 cannot be obtained, so they gave you 2 of them. And if you go through this whole process, you'll be able to find all these other ones. So in total, you've got 1, 2, 3, 4, 5, 6 of them. All right? So number 23, the answer is E. A triangle can be formed having sides 4, 5, and 8. It is impossible, however, to construct a triangle with sides 4, 5, and 9. Ron has 8 sticks, each having an integer length. He observes that he cannot form a triangle using any of these 3 sticks as side lengths. The shortest possible length of the longest of the 8 sticks is. So if you have a triangle, right? Any triangle like that. And you have, say, like they gave us in our question, sides of 4, 5, and 8. You can draw this triangle, no problem. But what about if you have a triangle with these sides, 4, 5, 9? Can you form a triangle? Well, one side is 4. Another side is 5. And then we want the longest side to be 9. Well, I can't exactly form a triangle because 4 plus 5 is equal to 9. So as you can see, it's impossible to make a triangle because if you have a triangle with 3 sides, ABC, A plus B must be greater than C. If you have that scenario, like this scenario, 4 plus 5 is greater than 8, you can make a triangle. But in this scenario, 4 plus 5 is equal to 9, so this is not possible. You can't make a triangle. So if A plus B is equal to C, triangle not possible. So that's the fundamental rule that we need to use in this question. So we are given 8 sticks, right? So we got 1, 2, 3, 4, 5, 6, 7, 8 sticks. And each of these 8 sticks has an integer as its value. And he's noticing that he cannot form a triangle with any of these 3 sticks. And they want you to figure out the shortest possible length of the longest stick, which I'm denoting as the final one because I'm going to have numbers in increasing order from smallest to largest. All right, no problem. Let's start with this. We want the shortest possible length of the longest stick. So we want shortest. We're concentrating on smallest numbers possible. So the first number, the smallest number possible, is 1, right? That's the smallest integer. The second number, the smallest possible number, is 1 also. And how about the third number? Let's make that a 1. All right, keep going like that, and therefore this is going to be a 1, right? But 1 is not part of the answer choices, so that must make you think, okay, I did something wrong. The reason is because if you made the first 3 1 1 1, you can form a triangle with 1 1 1. It will be an equilateral triangle of side length 1. So obviously that's not good. How do we proceed here and have a scenario where you cannot get a triangle? Well, it's this rule right here. A plus B has to be equal to C. So if this is A and this is B, our C has to be A plus B, which is 2, right? So far in the question, if these are the sticks, side length 1, 1, and 2, it's impossible to make a triangle. All right? So you just continue like that. How about the next number here? Well, similarly, we have to add 1 and 2, and that becomes a 3. If you do that, these 3 can never be used to make a triangle. And very similarly, that number will be 2 plus 5, 2 plus 3, which is 5. And if you do that, A plus B is equal to C in this scenario. And these 3 sticks would not be able to form a triangle. And very similarly, you just keep going like that. 3 plus 5 is 8, 5 plus 8 is 13, and 8 plus 13 is 21. So 21 is the length of that final stick, which is the longest stick, and 21 is the shortest possible length of that longest stick. So that would mean choice B. And if you're interested in these types of sequences, this is called a Fibonacci sequence. And if you want to become better at these kinds of questions, please read about this on the internet. Tony and Maria are training for a race by running all the way up and down a 700 meters long ski slope. They each run up the slope at different constant speeds. Coming down the slope, each runs at double his or her uphill speed. Maria reaches the top first and immediately starts running back down, meeting Tony 70 meters from the top. When Maria reaches the bottom, how far behind is Tony? So let's draw a diagram and explain this question. So you've got the ski slope all the way to the top and all the way to the bottom, like that. And that's going to be a right triangle, but I don't know if that's needed. And first, let's draw the path taken by Maria. We'll put her in orange. She goes up, all the way up like that. She gets to the top, and then she immediately starts coming back down. Okay? And when she is right here, so at this point right here, she catches up with Tony, and they've told you that that is 70 meters from the top, right there. They tell you that in the question. So Tony will have his path in green. He is going up the hill like that. And when he gets to that point, him and Maria meet for the first time. Okay? And then the second scenario is similar as you continue this race, I guess, what's what they call it, where Maria, she went all the way up, and then now she's coming all the way back down, and she reaches the bottom. But at this point, Tony is still running, right? He went all the way up, and he's coming back down, and he's going to be at a certain point when Maria reaches the bottom. So they are asking us, when Maria does reach the bottom, where is Tony? So if Tony is here, what is the distance from there to there? All right? So I hope that makes sense. If so, let's proceed with the mathematics of this. Well, there's a very important formula that speed is equal to, too many e's there, speed is equal to distance over time, right? So for example, they always say kilometers per hour or meters per second. Now this can be changed in any way you want. You can make it time is equal to distance over speed, and so on. So we will definitely need to use this formula. Okay? Now, the first thing, of course, is we have Maria and we have Tony. This scenario right here, let's concentrate on that. So scenario number 1. When Maria is going up the hill, she has to travel 700 meters because that is the length of the ski slope. And her speed, so this is the distance, her speed, we don't know. So we'll just call it x, no problem. X meters per second. Okay. Tony, when he goes up, he also is going up the same distance, 700 meters. But he meets Maria at this point right there, which is 70 meters from the top. So he actually doesn't travel a full 700 meters. He travels 700 minus 70, 630 meters. Correct? And we'll make his speed y meters per second. Okay? Now, is that Maria's full journey? No, she went up 700 meters, but she went back down 70. So she has a down segment of 70 meters. And what's her speed when she goes down? Read the question. Coming down the slope, each runs at double his or her uphill speed. So if she went uphill at x meters per second, she's going down at 2x meters per second. All right? So far so good. I hope you're following. I hope that makes sense. Okay, so let's move up here. Now they meet at the same time. Their times are the same at this point right there. All right? So that means we have to figure out time. We have to use this equation here. So for Maria, the time would be distance over speed. So 700 over x going uphill, and distance over speed going downhill, which is 70 over 2x. Right? Time for Tony is the distance divided by the speed, which is y. And these two times are equal because that's how they meet. They meet at the same time. So we can set them equal to each other. So let's set them equal to each other. So we got 700 over x plus 70 over 2x is equal to 630 over y. All right, this looks like a common denominator is going to be 2x, so multiply top and bottom by 2. So this becomes 1400 plus 70 all over 2x. Or if you want something a little bit more simpler, you can probably just divide through this guy here. So 700 over x plus 35 over x. There you go. It makes it easier. 630 over y. And this becomes 735 over x is 630 over y. And therefore 735y is equal to 630x. And let's see, this probably has, if you divide through by 5, 147y and 126x, divide through by 49, or divide through by 3, let's say. This gives you 49 and 42. Oh, divide through by 7, there you go. 7y, 6x. There you go. 7y is equal to 6x. So we can deduce from this that x, if we let it equal 7 meters per second, and y therefore will be 6 meters per second. We can work with these. As long as we hold this relationship, we should be okay. By inspection, I'm getting these two speeds. So now let's go back, and now let's look at this scenario right here. Scenario number 2. Okay, so I'm going to write my speeds here. X was 7 and y was 6. All right. Now this scenario, number 2, what's happening is Maria goes all the way up and she's come all the way down, right? That's Maria represented by the orange lines. Tony has gone all the way up and come back down until this point right here, and he's represented by the green line. So in a very similar way, we have to now figure out this distance right there. From the time that Maria reaches the bottom, where is Tony? So when Maria went up the hill, she has a speed of 7 meters per second, and her distance is 700 meters. When she went down the hill, all the way down to the bottom, 700, same distance, but her speed is double, remember. When she goes down the hill, it's double. So this is distance, this is speed. So we have to figure out her time, total time, going all the way up, going all the way down. Well, time, if you remember, was distance over speed. So going up, it's 700 over 7 plus 700 over 14 for when she goes back down. So this looks like 100 plus 50, so 150 seconds. So she takes 150 seconds to go all the way up and all the way down. All right, keep that in mind. Now, we turn our attention to Tony. How much time does it take him to go all the way up the hill? Well, he goes up the hill. The distance is, of course, 700. And his speed is 6 meters per second. So when he goes up the hill, his time is 700 over 6, which is equal to 116.66 seconds. All right? So from the bottom to the top, it takes him 116. Now, we have to understand that Maria takes 150 seconds to go up and down. He's already traveled for 116 seconds. So he has how much more time to travel? He has to travel an additional 150 minus 116.66 seconds, which is 33.33. Correct? Because Maria traveled up the hill in 150 seconds, and then when she came all the way back down, Tony had only reached this point right here. But it took him 116 seconds to get all the way to the top, so the remaining amount of time is how much time it took him to get to that point. So we have to figure out his distance after 33.33 seconds going downhill. So now we've got time is equal to 33.33, and distance is what we're trying to figure out, and speed. What's our speed going downhill? It's 2 times 6, remember? So it's 12 meters per second. So what is our formula for distance, speed, and time? Remember, speed is equal to distance over time. And therefore, if we want to figure out distance, distance would be equal to speed times time, like that. So distance in this case, speed is 12 meters per second, time is 33 seconds, 33.33. So this equals 400. So that means from here to here is 400 for him, for Tony. From here to here, all right, is 400. But we want to find this distance. Well, the total distance of the hill is 700, so that distance is 700 minus 400, which is 300. So when Maria finishes this race, Tony is at this point, and that point is 300 meters from the bottom. And therefore, the answer for number 25 is D.